Hello, welcome to 7.3, where we're going to talk about logarithms. So this is kind of a new thing, so let's get into it. Okay, so we've been talking about exponentials, so like 3 to the power of 6x or something like that. So this whole idea of exponentials is very important. So we need a function to be able to do more with exponential functions. So that's where logarithmics come in. So that is essentially what is a logarithm. It's just a way or a function that we can use to work with and manipulate exponents. So it says logarithmic form. So this reads log base b of a equals x. So we've got a little cheat sheet right there. So log base b of a equals x. And so what that means is if we were to put that in exponential form, so it's the same, we can say, so log base b, so b is our base, and then we switch the a and the x. So log base b of x equals a. So this is really important. We're going to be hitting this pretty hard because you're going to use that over and over again. So this is one of those fundamental skills that we have to build on. So make sure you understand this and make sure that we practice this. So think about it in your head, figure out a way to remember it. I always remember, so for some odd reason I can read it just fine. So log base b of a. So log base b, so I know that's my base, of a equals x. So and then I just remember to switch the a and the x, because in my brain log base b, got that, and then I have to do something with the a and the x. I just remember that something, and so they just end up switching places. So let's do some examples, see what it looks like in real life. Okay, so here we go. We're just going to go down and do examples 1, 3, and 5. So I'm looking at this. It says log base 3 of 9 equals 2. So log base 3 is my base, and then the 2 and the 9 switch places. So equals 9. So which that does make sense, right? 3 squared does in fact equal 9. Okay, so we're good. So then number 3, log base 7. So 7 is my base, and then we switch the 1 and the 0. Log base 7 of 1 equals 0. So like I said, log base 7, we got the 7, and then we switch the 1 and the 0. Again, 7 raised to the 0th power is 1, so we should be in good shape. So number 5, log base 4, there's a fraction here, but don't worry about it. Log base 4 of 1/16 equals -2. So the 1/16 and -2 switch places. So does that make sense? And if you think about it, yes, it does. So 4 raised to the -2th power, second power, is the same as 1 over 4 squared. And then, we multiply that out is 1 over 16. So we're so far in good shape. Okay, what about going the other direction? So we've got an exponent, let's write it in logarithmic form. So again, I always just focus on the bases. So log base, this is my base, that 14 is my base. So I'm gonna write log base 14, and then the 2 and the 196 switch places. So 196 equals 2. So log base 14 of 196 equals 2. So again, in my brain, that's how it works. I need you to figure out how it works in your brain and make sure it sticks. So log base 12. So log base 12 of 12 equals 1. So again, that still kind of makes sense. If we look at 12 to the first power, still equals 12. No problems there. So again, log base. So my base here is 2. So I'm going to have log base 2, and then 1 over 8 and the -3 are going to switch. So log base 2 of 1/8 equals -3. So just like some of our other functions, for example, like our square root, if there's no number right here, that's an implied 2. So there's just some really common examples, and that's when sometimes we get lazy and we don't write the number. So logarithms are no exception. So a logarithm with a base of 10 is called a common logarithm and can be written without a base. So what that looks like, log base 10 of x, you can just say log of x. If there's no number there, it's an implied base 10. So we're going to use that, and we're going to try to actually solve and evaluate some of these logarithms. So the directions say use your knowledge of exponents to evaluate the following logarithms. Basically, we're going to turn them into exponential form, and then we're going to try to figure them out. So log base 7, we can say this equals, this equals x. Log base 7 of 49 equals x. So I just switched my x and my 49. So now what number do I need to put there? X equals 2. So then if we look at number 15, the same process goes along. So here we don't have a number here, so that is an implied 10. So we have log base 10, log base 10 of 100 equals x. And so my x and my 100 switch places, and again, my x is going to equal 2. If you don't know that off the top of your head, then I would just maybe use your calculator, do like x to the first, x to the second, x to the third, and try to figure it out until you get to something that makes sense. So number 17, log base 2 of 64, we're going to say equals x. I'm going to do log base 2, so 2 is my base, raise the x power equals 64. And so this is actually where I would just use my calculator, and there's a variety of different ways. You can even shove it into the y equals mx and make a chart. That might be easier, I don't know. But as you go through, once you figure out that x equals 6, so 2 to the 6th power is going to be 64. So x equals 6. So this is more of less math and more just puzzle, trying to figure it out using your brain, using your logic to try to figure it out. There's not really a good process that I can give you to immediately solve this yet. So log base 9 of 1 over 81, again, we're going to say that equals x. So log base 9, so 9 is my base, raise the power of x equals, so when I'm looking at this, I immediately see, I guess I should finish writing that out, 1 over 81. So I immediately see that this is a fraction. It's a fraction! But that's not too big of a deal. So I know that my x is going to be a negative number, because 9 to the negative number is going to give me a fraction. And then 81 is just 9 squared. So in this case, my x is going to be equal to negative 2. So again, you need to use those kind of patterns that you've seen and try to figure this stuff out. Okay, so to be completely honest, in I guess normal mathematics, whenever you are trying to solve a problem, maybe in like physics or whatever, having a log base of something other than 10 or e, which we haven't learned yet, is very rare. So what we need to be able to do is change this into something that's more useful, and that is using the log base 10. So if you haven't figured out on your calculator, there's a log button. It just says log, but that is log base 10. So let's say we've got something like 21. We want to change that to log base 10. So we need a formula to do that. So if you look right up here, our formula to do that is log base b of a is equal to log of a over log of b. So the way I remember that is the log of a is kind of my big number, goes on top. Log of b is kind of my little number, goes on bottom. I can kind of see a little fraction. I'm a visual person, I guess. So I see my fraction right there. So the A goes on top and the B goes on bottom. So let's try that out. Let's see what it does. So looking at 21, we've got log base 16 of 64. You know, I can't figure that I can't figure that out off the top of my head. So I'm going to use that formula. So log base 10 of 64 over log of 16. So from there, you can probably put it into exponential form and then figure something out. But I'm just going to plug it in my calculator. I'm going to push the log button. So I'm going to do log of 64, close parenthesis, divided by log of 16, close parenthesis, and it's going to tell me it equals 1.5. I'm sure somebody could figure that out without a calculator, but, you know, what's the point, right? Anyway, looking at 23, so log base 2. So we've got log of 54 over log, wow. I'm experimenting with cursive, see if it looks better, but I don't know that it does. Anyway, log of 54 over log of 2. I'm going to just plug that into my calculator. Log of 54 divided by log of 2 equals a weird, nasty number. So we're going to say 5.755, something like that. Okay, this last one, I actually want to show you how it looks like on the calculator. So it's log base 4 of 136. So we're going to change it to regular log or log base 10 of 136 over log of 4. So you're just going to have to kind of remember that while we go to our calculator. So what that's going to look like on your calculator is we're going to use this log button right there. But you'll notice that whenever we push the log button, our parentheses open. So again, it was log, we had log of 136 over log of 4. So log of 136, notice how you have to close your parentheses. If you don't remember to close your parentheses, your calculator is going to give you the wrong answer. Because basically you're using a single log and you're shoving that whole fraction in. We don't want to do that. So log base 10 of 136 divided by log, and again, it opens a parenthesis. Now here's where the closing the parentheses is probably more for humanistic. The computer knows that if there's nothing left, that they just close the parenthesis. I would do it anyway just because it's a good practice. But we're going to push enter, and our answer is 3.54. We'll say 2 decimal points is fine. So 3.54. 3.54. So equals 3.54. So there you go. Welcome to the world of logarithms. It's going to change your world.